Hello students, today we are going to discuss ray optics. We know optics is the branch of physics where the properties of light is discussed. In our nature we observe different natural things which are related to light, and to discuss or to understand why these things happens in our nature, we use some consideration about light. These considerations comes according to the observations. If we like to explain how a image is formed in a mirror or how a magnifying glass works, we consider light as a ray. But to explain other natural phenomena, that is why our sky appears blue or why during sunset or sun rays the sky appears red, we consider light as a wave. Then we never consider light as a ray. Then we consider light as a wave. Again, to explain the photoelectric effect, that is electrical energy generated from the solar energy, we consider light as a particle. So light is a single thing, but in different cases, that is to explain different natural activities, sometimes we consider light as a ray, again sometimes we consider light as a wave, and sometimes we consider light as a particle. So according to our consideration, this optics divided into three different parts. First is ray optics or geometrical optics. Second, wave optics or physical optics, and third, quantum optics. So ray optics is the branch of optics where we discuss or where we consider light as a ray. In case of wave optics, we consider light as a wave, and in quantum optics, we consider light as a particle. And these ray optics and wave optics both are the part of classical optics. Okay, so our study is limited to ray optics in this session. Then we will learn about wave optics, and last we also learn about quantum optics in photoelectric effect. Okay, the medium through which light travels is divided also in three different parts. There are some mediums in which light can travel very easily, and very less amount of energy actually dissipated during this transmission of light. Those medium are called transparent medium, like glass, glycerin. Through these materials light can travel very easily. There are also some materials through which light can't travel, like wood, wall. These are called opaque medium. Through these medium light can't travel. And there are also a type of medium in which light can travel a certain distance, or light can travel partially, not completely. Like through oil, light can't travel a long distance as the energy of the light dissipated very fast. These type of mediums are called translucent medium. So mediums are classified into three different parts. One is transparent medium, second is translucent medium, and third is opaque medium. So there are three different types of medium. One is transparent, that is through which light can travel very easily. Translucent medium, the medium through which light can't travel very easily. After traveling some distance, the energy of the light dissipated completely, so light stops traveling. And opaque medium is the type of medium in which light can't travel. So these are the three different types of medium. So next, nature of light. We know in a specific medium light travels in a straight line. This property of light known as rectilinear propagation of light, and we can represent a light ray by a straight line. One straight line represent a single ray of light, and if I represent 3 straight line, then these 3 straight line will represent 3 ray of light. Okay, next, a bundle of rays is known as beam of light. Bundle of ray is called as beam of light, and this beam of light can be divided also in 3 different parts. Okay, this beam of light can be divided into 3 different parts. One is converging beam of light, second parallel beam of light, and third diverging beam of light. What is converging beam of light? It states that if beam of rays meet at a point, then those rays are called converging beam of rays. That is, if some rays meet at a point. So, seeing it A, this is called converging rays. Those rays are called converging rays. And if the rays remains parallel with each other, then those rays are called parallel beam of rays. This is B. And if the rays diverges from any point, then those rays are called diverging rays. So, if I consider it as a light, then we know from the light rays travels in all directions. So, this is the source of light, and from the source of light, the light rays always diverges. So, these rays are called diverging rays. If the rays meet at a point, then those rays are called converging rays. If the rays of light remains parallel with each other, then those rays are called parallel beam of rays. And if the rays emitted from a point, then those rays are called diverging rays. Whenever light falls on a surface, then 3 different things may happen. The very first thing is, if I consider it as a second medium, and this is the first medium, a source of light is present in here, and when the light falls on it, 3 different things may happen. The very first thing is, some part of the light will be reflected back in the first medium. Some part of the light energy absorbed by the surface, and if the second medium is transparent or translucent, refraction will also occur. That is, some part of the light travels through the second medium. In case of transparent, the light will travel completely. In case of translucent, the light may reach to the end of the second surface or may not reach. But in case of transparent medium, the light will obviously refract through the second medium. So, if a light falls on a surface, 3 different things may happen. Some part of the light energy will be reflected back, some part of the light energy will be absorbed by the surface, and if the surface is transparent, then reflection will also occur. So, first we are going to learn about reflection, then we will move to the refraction. So, we know reflection is the bouncing back of the light by a surface from one medium to the same medium, and based on the reflecting surface, there are 2 different types of reflection occur. One is regular or peculiar reflection, and another is irregular or diffused reflection. So based on the nature of reflecting surface, reflection edge of into two parts. One is regular or peculiar, and second irregular or diffused reflection. What is regular reflection? If I consider it as a smooth surface and some parallel beam of rays incident on that surface, then after a reflection those rays will reflect parallelly with each other. This is the regular reflection. And irregular reflection or diffused reflection is the type of reflection in which if some parallel beam of rays incident on a rough surface, then after reflection the rays moves in different directions. This is called irregular or diffused reflections. So we able to see our nearby things due to this diffused reflection. During daytime we can see everything in our room, though sunlight never falls directly in our room due to this diffused reflection, as the particles of our atmosphere actually reflect the sun rays in this process. Okay, next, laws of reflection. There are two definite laws of reflection. So first law of reflection states that the angle of incidence is equals to the angle of reflection. I think you know about angle of incidence, angle of reflection, incident ray, reflected ray. If you forgot, just a rough idea. If I give it a name O, this is A, this is B, it CD. CD is the reflecting surface, that is a reflector. AO is the incident ray. ON is the normal. OB is the reflected ray. O is the point of incidence, and the angle made by the incident ray with the normal is called angle of incidence, and the angle made by the reflected ray with the normal is called angle of reflection. And this law holds for any type of surface. You must have to understand, any type of surface, maybe it is convex, maybe it is concave, plane, rough, whatever the nature of the surface is, this law holds everywhere. The angle of incidence is equals to the angle of reflection. And second law states that this incident ray, the reflected ray, and the normal drawn at the point of incidence lies on a same plane. Incident ray, the reflected ray, and the normal all lie on a same plane. Okay, so that is, it's not possible if I consider my palm is a surface, the light rays fall on it in this direction, it will move in this direction. It's not possible that light falls on it from this direction and travels through this direction. It's not possible. Both the incident ray, the reflected ray, and the normal will always lie on a same plane. And if the light falls in this direction and travels in this direction, so this will be not a plane surface. So this is not possible at all. Okay. Next, what do you mean by object and image? We know object is defined as the source of light, maybe direct source of light or indirect source of light. Like sun is the direct source of light, we call it as a luminous source of light, and moon, our chair, tables are the indirect source of light, that is, they reflect the light of the sun or other luminous objects. So these non-luminous objects also act as a source of light. So if we like to define the object, then we can say any type of source of light may be luminous or non-luminous is defined as the object. And what is image? This is the optical counterpart of the object, that is what we observed after reflection or refraction is called image. Image may be real or may be virtual. What is real image? The type of image that forms when the rays coming from a source meet at a point after reflection or refraction. And what is virtual image? The type of image which forms when some light rays appears to meet at a point after a reflection or refraction. That is, if the rays meet at a point, then the image is called real image, and if the rays appear to meet at a point, then the image is called virtual image. A mirror, maybe it is a plane mirror or a curved mirror. It divides a space into two different portions. If I consider this is a plane mirror, this is a curved mirror, and it also acts as a curved mirror. So any type of mirror may be flat or may be curved. It divides medium in which it is kept into two different space. Let's consider this is the medium in which the mirror is kept. So this is the first portion and this is the second portion. This portion is called a real space and this portion is called virtual space, that is the back side of the mirror. We know this is the reflecting surface and this is the coated surface, and the light rays reflected by this surface. So this all portion is called real space and the backward portion is called virtual space. If any object is placed in this position or any image is formed in this position, then the nature of the image or object will be virtual. That is, if the object is placed in this place, the object is called virtual object, and if image is formed in this position, then we call the image as a virtual image. Same things happens for this curved mirror. This is the reflecting surface. So this space is called real space, this space is called virtual space. So any image formed in this zone is called divided. This is real space and this is virtual space. In case of this here, this is also called real space, this is virtual space. Any image that forms in the virtual space is of virtual nature, and any image that forms in the real space is of real nature. So by this basic rule you can find out the nature of the object. Is it real object or is it virtual object? There are other ways also, but this is also a process by which we can understand if a image is formed in this person or in this person or in this person, then the nature of the image will be virtual. But if the image is forms in this position or in this position or here, the nature of the image will be real. Okay. So next, formation of image by plane mirror. Next, classification of types of reflection. We already did it. One is regular, another is irregular. In case of regular reflection, the surface is smooth, and in case of irregular reflection, the surface is rough. But this smooth surface can be divided into two different parts. One is plane or flat surface, another is curved surface. This is the plane surface, this portion is the reflecting surface, and the another portion is coated. And in case of curved surface, it is also divided into two parts. One is convex, another is concave. What is convex? The type of reflecting surface in which the reflecting surface remains in the outward direction. Then the type of reflecting surface is called convex, and if the reflecting surface remains in the inward direction, then that type of surface is called concave. Okay, this regular reflection when occurs on a plane surface, those plane surfaces are defined as a mirror. So we can say plane or flat surface as a plane or flat mirror, curved surfaces as a curved mirror. So again the curved mirror is divided into two parts, one is convex mirror, another is concave mirror. So first we are going to learn about the properties of the images formed by plane or flat mirror. Okay, so plane mirror is a type of mirror that has a flat reflecting surface which produces a virtual and erect image of an real object. So let us consider it as a plane mirror, and here a point object is placed. So a light rays will travel in this direction, and as the rays falls normally on the surface, and in case of normal incidence, the light ray will be reflected back through the same path. So the light ray will reverse back in this direction, and another ray fall on this surface. If I draw a normal at this point, this is angle of incidence, so the ray will be reflected back in this direction, so this is angle of reflection. If we observe the ray from this position, that is, if we place our eye at this position, we can see the rays are coming from this point. In this case, this is the first ray reflected back in this direction, and this is the second ray reflected back in this direction. So the two rays move in this direction, so these two rays never going to meet in this zone. This is called our real space, so no real image will be formed. But if the rays enlarge in the backward direction, we can say the rays are going to meet at this point. So this is our virtual space, and then we see the image at this position of this point object. As the object is point object, so the image will be point image. Okay, and as this is the virtual space, or the rays appear to meet at this point, so the nature of the image will be virtual. Clear? Next, some basic properties of the image formed in this mirror. The very first property of the mirror is the size of the object is equals to the size of the imaged. That is, if we look into a looking glass, we can see that the size of the image formed by the looking glass is as our face. So there are no changes. Second property says that in case of image formation, in case of image formed by a plane mirror, the image is virtual in nature and also erect in nature. I think you know about the name erect. Erect means if the head of the object is in the upward direction, the head of the image of that object will be also in the upward direction. This is the object and this is the image. If the head of the object is in the upward direction and if the head of the image is also in the upward direction, then the image is called erect image. and if the head of the object is in the upward direction and the head of the image is in the downward direction, then the image is called inverted image. So in case of plane mirror, a erect and virtual image is formed. This is the second property. And the third property is that in case of image formation, the distance of the object from the mirror is equals to the distance of the image from the mirror. That is, if it is x centimeter, it is also x centimeter. This is called object distance, this is called image distance. We also can prove it very easily that if this angle is I, we also can say this angle is I. This is alternate anterior angle, and in this case if this angle is R, we can say this angle is also R. O in, if I give it name P, this is Q. You can say PQ and ON are parallel and QO is the intersector. So this angle is equals to this angle. It proves these things. This angle is equals to these angles. So if this angle is the R, it will be also R, and if this angle is the I, it will be also I. So we know according to the laws of reflection, angle of incidence equals to angle of reflection, that is I equals to R. So we can say the value of this angle is equal to the value of this angle. So from these two triangles, these angles are same. This is 90 degree and this is a common side. So side angle AAS. According to this law, so we can say, if I give it name POQR, suppose POR QOR. So from this condition we can say the length of the PR equals to RQ. So we can say that the distance of the object from the mirror is equals to the distance of the image from the mirror. And as the distances are same, for this region it happens in case of mirror, the left side of the object appears to become the right side of the image, and or the right side of the object appears to become the left side of the image. So there is a lateral inversion. The change of side takes place in this case. For this reason, if in a plane mirror, if we look this letter B, it will be like this. If we observe D, it will be like this. Like A, it looks like A. For O, it also looks like O. So for these letters, no changes are observed as they are symmetrical in shape. Okay. So these are the following factors and properties related to plane mirror. Next, there are few keywords. If you remember it, then it is going to help you in other exams also. First thing is that the length of a mirror must have to be the half of the height of the person to see the complete image of that person. If I consider a man of height 6 feet, the minimum length of the mirror that is required is 3 foot. That is, a half of the length of the person is required, and it's not important at all where the eye of the person is. It's not depends on the height of the eye from the ground or the distance of the person from the mirror. Whatever his distance from the mirror is, or at what height is his eye is not important at all. In each and every cases, the height of the mirror, minimum height of the mirror is equals to the half of the height of the person. In second case, in absence of this reflecting surface, the ray will travel in this direction. So here we have to find out the deviation. What do you mean by deviation? Deviation is the angle by which the light ray bend from its original path. So the original path of the light is AP, but light travels through OB. So this is the angle through which the ray is deviated. So we have to find out this deviation. We know this is angle of incidence I, again this is R. So I plus R plus delta equals to 180. This is the complete angle. Again we know from the laws of reflection that R equals to I. So I plus delta equals to 180. Delta equals to 180 minus 2I. This is the angle of deviation in case of plane mirror. This is the very first thing. Second thing is that if the reflecting surface rotated by an angle of theta, then we will see this reflected ray will bend by an angle of 2 theta. You just have to remember, if the reflecting surface rotated by an angle of theta, then the reflected ray will also rotate by an angle of 2 theta from its previous. These are the case of plane mirror, but if we use the combination of mirror, it is more than one mirror, then what will be the angle of deviation, and also what will be the number of images found by the combination of mirrors. We know for a plane mirror only a single mirror can produce a single image, but if we use more than one mirror, then what will be the number of images in that case. So let's consider two plane mirror kept at an angle of theta with each other. This angle is theta. A ray falls from this direction. This is the normal. So the ray will move in this direction. This is the path of the light ray. So what we have to find out, that the total deviation in this case. So first deviation occurs in this mirror and the second deviation occurs in this mirror. So total deviation equals to deviation in this mirror plus deviation in this mirror. If we add both, then we can find out. So let this is the incident angle I. So this angle will also be equals to I, and what will be the value of this angle? As this is the 90, so this will be 90 minus I. Okay, and next let consider it, this angle is R, so this will be also R and it will be 90 minus R. So this is the angle is 90 minus I, this is 90 minus R and this is theta. So we can say 90 minus I plus 90 minus R plus theta equals to 180, or 180 minus R plus theta equals to 180, or theta equals to I plus R. Okay, so the first angle of deviation in the first surface, angle of deviation in the first, the angle of deviation by the first surface. So angle of deviation by the first surface, delta 1 equals to 180 minus 2y by the second surface, delta 2 equals to 180 minus 2r. So net deviation delta equals to delta 1 plus delta 2 equals to 180 minus 2y plus 180 minus 2r equals to 360 minus 2I plus r equals to 360 minus 2 theta. So angle of deviation here, delta equals to 360 minus 2 theta, where theta is the angle between the two reflecting surface. So here the angle of deviation is independent of the angle of incidence. Whatever the value of angle of incidence, always the angle of deviation will be 360 minus 2 theta. Okay. So next, the number of images formed by the combination of mirrors. If we consider two mirrors kept at an angle of theta, then if an object is placed here, then what will be the total number of images formed by these two mirrors? Okay, so first, if 360 by theta gives even value, in that case, if the 360 by theta gives us even value, then number of images equals to 360 by theta minus 1. But if 360 by theta gives odd value, like if theta equals to 40 degree, then 360 by 40 equals to 9. In that case, what will happen? Now, it will arise two different conditions. First condition states that if the object is not on the bisector, by theta, and if the object is on the bisector, then number of images is 360 by theta minus 1. Okay, so these are the different number of images formed by the combination of mirrors. But you must have to remember one thing, that in case of multiple reflection, each and every time the energy of the incident light absorbed by the reflecting surface. So the intensity of the first image is much more than the intensity of the distant images. So with increase in the number of image, the intensity or the brightness of the image will also decrease. Next we will learn about curved surface in our next class. Thank you.